Hello, everybody. Welcome back to our math class. Well, here's another important question for us. Given a triangle ABC, is there any point in the plane that is at equal distance from points A, B, and C? Well, in a previous class, we actually discussed a little bit about points being at equal distance, but not from vertices of a triangle, but rather from just 2 points. Well, so let's see what's happening here. Well, what's happening is this. Let's say here's a triangle, ABC. Okay. Well, if we ignore the triangle for now, let's focus only on the two vertices B and C. Well, okay, if we take midpoint M here at BC, no? So BM is equal to MC. And we consider the segment bisector. Right, let me extend it as much as I have to here. All right, so if we consider the segment bisector of segment BC, we know that every single point on this segment bisector is at equal distance from B and C, no? So these two segments will be equal to each other. These two segments will be equal to each other and so on, no? All right. Good. So we got that from a previous class. Well, how about we do this? How about we take here N to be midpoint of the segment AB now? So BN is equal to NA. And construct again the segment bisector. Okay. Here's the segment bisector of the segment AB. Well, now as you can see, the two segment bisectors intersect here at point, let's call this point O, no? Well, on one hand, what's happening here is point O is on the segment bisector of segment BC, right? Well, what does that mean? It actually means that OB is equal to OC now. Well, let's put this in writing. So OB is equal to OC. Well, what else is going on here? Well, also, point O is on this other segment bisector, no? Of segment AB. So, again, what's going on here? OA is equal to OB now. So OB is equal to OA. Well, what does that mean? Well, from these two equalities, that means that OA is equal to OB is equal to OC. And this actually leads to two very important conclusions. On one hand, OA is equal to OC now, which means that if we actually construct the perpendicular from O onto AC, right? Again, just because OA is equal to OC, so this means that point O belongs to the segment bisector of segment AC now. Well, so now we just proved in a couple of lines really a key property, namely the three segment bisectors of segments AB, BC, and AC intersect at this point O. And this point, just because OA is equal to OB is equal to OC, tells us that there is a circle, right? So there is a circle centered at O of radius AO, and obviously there is going to be such circle, but this circle and this circle goes through A, B, and C simply because OA is equal to OB is equal to OC, which means that there is a circle that's circumscribed to triangle ABC, and the center of that circle is at the intersection of segment bisectors. And let me summarize this. Well, we have this idea of the circumscribed circle, no? Which says that given a triangle ABC, the segment bisectors of segments AB, BC, and AC intersect at the center of the circumscribed circle in triangle ABC. And just to look at the final diagram here, so if we've got a triangle ABC, like so, well, here's A, here's B, here's C, and we take the midpoint here of BC, and here's N, which is midpoint of AB, here's P, which is midpoint of AC, and we actually construct the segment bisectors. Okay, so these are perpendiculars right here. The three intersect at this point O, and this point O is actually very, very important because it has this very interesting property that it is the center of the circle going through points A, B, and C, and this circle is the circumscribed circle of triangle ABC. Again, the center of it is at the intersection of the three segment bisectors of segments AB, AC, and BC. All right. Thank you very much, and see you at our next class.